Today we are working on a power to a power, power to a product, and power to a quotient. So for our first rule, a power to a power is when you have an exponent inside parentheses and another power or exponent outside the parentheses. The rule is that you multiply them. You multiply the exponents. For example, if we had n to the third power times the second power, that would mean I've got n to the third, and then if I had to square that, it would equal n to the third times n to the third, right? And altogether, what would we get? N to the sixth. So we may as well use our shortcut rule is when there is a power inside and outside, that's called our power to a power. We multiply those exponents, and that becomes n to the sixth. Question. Yes?
But wouldn't it be like, never mind.
All right, can I move on? Yeah? Who's still writing? All right, so let's try a few. Okay, I'm going to do the first one. Remember, when we have it out, a power inside and outside the parentheses, we are multiplying. So this really means y to the third power times the fourth power, which is equal to y to the 12th. You guys go, do 2, 3, and 4. Pause the recording. Okay, let's go with Dakota, number 2.
Okay, so then you do n 3 times 5, 2, 3 times 5, which equals n to the 15th.
Perfect. Next one. Let's go with Annabella.
T to the 2 times 3, which is
Power
to the,
is
T to the 6th power.
good. Next one, let's go with Alana.
K to the 7th power, and to the second is,
Times the second power.
times the second power is K to the 14th.
Good. Pretty easy. Okay, moving on. Now we're going to do a product to a power. Yes.
On the last one, on number 3, the exponent outside of the parentheses wasn't higher than others.
It's just the way it's done with the PowerPoint. It's hard to get things exactly, but they're both to a higher point. Maybe it's not as high. Yes.
Is that how you say it? You say like K to the
Second power times the third power. Or K to the 7th power times the second power is K to the 14th power. Yes.
Can you have an exponent to an exponent?
Well, we're going to see. Yes. Well, that was a power to a power.
No, but n to the second power.
Let's stay with this, okay? So, product to a power to a power. Okay? So, what that means is we're multiplying inside, and if everything inside is to the nth power. I don't want you to think of this as distributing. Distributing is over a plus or minus sign, like 2 times 3x plus 4. Then you multiply here and multiply here. It's over a plus sign. This is not distributing. Everything in there is to the nth power. Okay? Do not call it distributing. We distribute over a plus sign. So x is to the nth power, y is to the nth power. So when I'm here, I'm basically saying 3 is squared and x is squared. So altogether, that makes 9x squared. Pause the recording and try the next 3 on your own. Okay, number 2, raise your hand. You haven't been called on yet. Adam? Matthew?
I got 8 and y to the 3rd power.
Good. 2 is cubed, y is cubed, so we get 8y to the 3rd. Next one, number 3, Roman.
25m to the 2nd power.
Correct. Remember that negative is also squared. Negative is squared, 5 is squared, and m is squared. So it's positive 25m squared. And then the last one, how about Sage?
64 to the 3rd.
Right, 4 to the third, t to the third, so it's 64 t to the third. Questions? Yes.
What if it's like, in parentheses, 4t times like 100?
In the parenthesis, and the whole thing is to the third?
To like a 100.
So like you had something like 4t, and it's to the 100th power, like that?
Yeah.
Well, 4 would be to the 100th power, and t would be to the 100th power. They're not likely going to give you something like that unless you have a calculator. You're not going to be using big numbers like that unless,
But would you have to solve, like,
not without a calculator. And then you would do 4 to the 100th power, carry it to the 100th. All right. So now let's look at a power within a power. Let's stay present with this. Okay. Okay, so now we have everything in here. -2 is to the 4th power. A squared times the 4th power, because it's inside outside. B cubed times the 4th power. And C is the first times the 4th power. What does that simplify to? This I want you to write out. Got it, Cameron? These I want you to write out for homework. David? Because they're getting more complicated. So what does this become? 16, A to the 8th, B to the 12th, C to the 4th. Does that make sense? I'd like you to pause the recording and do the next two on your own. Here we go. So, first, what am I doing? Rami?
So first
We don't distribute.
I first put
Shh.
the exponent, like I said, -5 to the second,
Good.
x to the second,
Good.
y to the 10th power times the second power,
Good.
z to the third power times the second power.
And I love the way he articulated that. He said it perfectly. Okay, and then it simplifies to?
I got 25x to the second power, y to the 20th power, and z to the 6th power.
Perfect. Okay, next one. Cameron.
So, first, because we have to do exponents first. And
Is -8 squared?
no.
So I'm just going to write that down. -8.
Oh yeah. And then and 3.
What's the operation?
Oh, distributing.
No, there's no distributing. There's no plus signs. What's the operation when something's next to? So we say times.
Oh, yeah.
Times what?
2. Wait.
n
Oh, n to the third power times 2.
Times the second power.
Second power. P to the fourth power.
Times P.
Times P to the fourth power times the second power.
Good.
Times T to the times
To the.
to the 0 power times 2 times the second power.
Good. Okay. Now what does it simplify to?
-8 n to the 6th, p to the 8th, t to the 1st.
And not to the first.
Or just t.
T to the 0, which equals. Anything to the 0 power equals what? Anything to the 0 power. T to the 0 power equals 1. Times 1. I don't need to write that. So it's just -8 n to the 6th, p to the 8th. Anything to the 0 power equals 1. Let me go back and explain that. If I have x to the third over x to the third, right? This means x times x times x over x times x times x. When I cross cancel, I'm left with a 1. So when it looks like there's nothing left, we're really left with 1 times 1 times 1 over 1 times 1 times 1, which is 1. If I do the shortcut, x to the third minus the third, we get x to the 0. Same thing, right? When dividing fractions, we can do this. So x to the third and 1 equal the same thing. Because when they get cross-canceled, what's left up here are all these 1s. Okay? Anything to the 0 power. 100 to the 0 power equals 1. Okay? And when you're doing t to the 0 times 2, that becomes t to the 0 power, and that really equals 1. Got it? And I don't need to write the 1, we just write this. Okay. Let's try we're going to skip these and go on to now combining what we did yesterday and today. The danger in these kinds of problems, and this is why I really need you paying attention, is there's a lot of little easies. Everything's easy. It's easy, it's easy, it's easy. And then when you put all these easy little rules, they're like negatives. They get in there and they mess you up because there's a lot of little easy things to do. And when you put it all together, people start to confuse the rules. Okay? So you need to pay attention to the details of the lecture. All right. So problem number 1, we're just going to do the first part. It's not problem number 1. Whoops. You need to first find the power to the power for that part. Okay, so Fatima, what would that simplify to?
It'd be 3 to the second, 3 squared.
Uh-huh.
Times x to the x squared times the second power.
Good.
Times
Shh.
y to the third power times the second power.
And what does that simplify to?
9 x to the fourth and y to the sixth.
Okay, Carter, knock it off. Whatever you're doing, you guys stay present. I just told you this is some of the most... Now, you can expand it out, but you can go right to the 9x to the 4th power. Okay, now I'm multiplying that now times this. Carter, next one. Times what?
You multiply, wait, what?
What do I keep doing?
Oh, that, you times it by, you write everything out, so you do like, -4 in parentheses to the second.
Keep with this.
Wait, what?
Look what I've done. Continue.
Continue on the left side?
Somebody that's with us.
It would be 8x to the second power.
No, not 8,
Oh,
because it's -4
sorry.
squared.
16x to the second power.
16, x is to the second, and y is to the
Fourth.
4th.
Sorry, my bad.
Okay? Now, before we were doing power to a power and multiplying the powers, now, what do we do? Because this is just straight multiplication. Okay, Eitan?
We multiplied the numbers, so we add the exponents.
First, before that, start left to right. We don't start in the middle of it.
So we add the coefficients.
We don't add them. Go.
You multiply the coefficients.
Which would make 144. And then what am I doing with x to the 4th and x to the 2nd? What do I do with those? Go.
You add up the exponent.
Right? And that becomes
X to the 6.
x to the 6. So we go into multiplying rule, which is really adding the exponents, not the coefficients. And then what do I end up with, Eitan? Y to the
10th.
Good. Okay, you guys try the next one. Go. Number 2. What do I get for the first half? Let's go. Okay, Carter, try it again.
You get 4a to the 6th, e to the 10th, c to the 2nd,
C to the 2nd times
times negative 8a to the 3rd, b to the
8, a to the 3rd, b to the
12th.
12th. And then when we multiply those out, let's go. Matthew?
Negative 32.
Uh-huh.
A to the 9th. B to the 22nd.
Okay.
And C to the 2nd.
Good. Questions? Okay. Moving on. Now, power to a quotient, I hope.
Do we know what shows us the multiplication of the quotient of one power?
Do your best. Okay. So, next one. Power to a quotient. Again, we are not distributing. Do not call this distributing. It's not over a plus or minus sign. But everything in there is squared. You can show this in two ways. You can say 2 is squared and x is squared. Over. The bigger they are, the more work I want you to show. Do you understand? If they're easy and simple and small, you can do the mental math. But the bigger the problems are, that's when you should be expanding. And then that ends up being 4x squared and 5 is squared. Sorry. My pen is x squared and over 25. Okay? Another way to show that, can I erase? Yeah. Another way to show that would be, you could do 2x squared, 2x times 2x, right? Or you can go just here. As long as you have the visuals so that you don't make the mistakes. Why don't you try number 2? Go. Pause the recording. Let's hear from somebody I haven't heard from. David?
So you
Whoops.
equal to, wait, I just say what it's equal to, right?
No, tell me what to do.
5, you squared 5.
Square, 5 squared?
5 squared, and then you multiply the exponents for a, so it's a to the 4th.
A second power times the second power.
Times the second.
B to the
B to the 4th power times the second power.
all over.
3 to the second power.
Good, and it simplifies to?
Simplifies to 25, a to the 4th power, b to the 8th power over 9.
Over 9. Now, if you have to cross cancel at this point, you got to cross cancel. Believe me, there will be plenty of that. I want to go over really quick what happens if we have a negative exponent. So if I have that negative exponent like 2x squared y over 3, and the whole thing is to the negative 4th power, the very first thing we're going to do is reciprocate it, right? So I get 3 over 2x squared y. Everything is to the 4th power. So 3 is to the 4th, 2 is to the 4th, x squared times the 4th, y to the 4th. Okay? That would be 81 over 16, x to the 8th, y to the 4th. Does that make sense?
Yes.
All right, and that is our lesson.
Don't erase that. I want to copy